Hello guys, in this video I'm going to show you how to solve order-agnostic search. It is a modified version of binary search. So before jumping into a problem, I want to brush up our knowledge about binary search. So the important requirement for binary search is we must have a sorted array. So for this example, is an ascending order binary search, right? So the target that we want to find is phi, and in order to do the search, we first find the middle elements of the input, which is in this case is 4. So phi is greater than 4, so what we need to find is must be on the right of 4, right? So we limit our search by half, right? So we remove everything from 1 to 4 and from our search space, right? And by recursively repeatedly doing that, we end up with our number. So we start searching from 5 to 7. Okay, compare 5 with 6, which is the middle number. 5 is less than 6, so it's on the left of 6, right? Only care about this part. So we left with 5. So 5 to 5 is 5. Then we found it. Just return the index. But our problem is order agnostic binary search. So we don't know whether it's sorted or whether it's sorted in ascending or descending order, and also array can have duplicates, right? So the only difference here is we don't know beforehand that it is sorted in which order, ascending or descending. So probably before doing search, we want to check if it's ascending order or descending order just by comparing the first and the last number, right? So I will store it in a variable ascending is ascending. It is ascending when the first element less than the last element, which is at index length -1. So from here we start our search. The code is pretty much the same as a binary search, in normal binary search. So we need to keep track of left and right pointers. The left start with 0, right? The right, so this guy, here's the left, is right, we keep two pointer. Right is right, length minus 1, index of last item is length minus 1, and we want to run into a loop as long as the left is less than or equal to right. When the left is less than right, it's probably because the item is not, the target is not in our input, our array, input array. So here I want to find the middle index, right? Middle index. The middle index, I can simply add the left and right and minus 2, but this can cause overflow, because if left and right is too big, and two big numbers, one a big numbers plus a big number can cause error. So I want to avoid that by a simple check, which is I'm gonna take the left plus right minus left divided by 2, right? So for example, we have 6, 7, 8, right? So the left is 6, right? 6 plus 8 minus 6 is 2. 2 divided by 2 is 1. So we get the middle index, which is 7, right? With this formula. So after get the middle index, I will compare it with our target. If our target is equal to the item at middle index, we'll return the middle index, right? And here's the different part, because here I don't know about about whether which order it is sorted, so probably I will break it down into two cases here. If the ascending order, I want to do the logics, else I do the other logic. So if it is ascending order, I will compare the target, right? If the target is greater than our middle, it means it's on the right because it's ascending order, right? L is in the left. If it's in the right, I probably want to update our left and right pointer, and because we want to ignore everything on the left, right? So I will update the left pointer, right? For example, here we keep a middle index, right? So if we know that 5 is on the right? Because it's greater than 4. I want to update the left to 5, and everything is ignored, everything on the left is ignored, I will start our search again from within the left and right limit. So left is middle plus 1, right? Here the middle, left is middle plus 1, right? But if it is less than the middle, it means it's on the left. I want to update the right pointer, which is middle minus 1. And if it is descending order, I just simply reverse this logic. I just reverse it, right? So if left greater than right, I will exit the loop. It means we couldn't find the target. So I return minus 1 and run the test. Alright, it worked. So thank you for watching. See you in the next video.